In our next section, we're going to look at BGP traffic engineering by using communities and specifically talk about RFC 1998, which is an application of the BGP community attribute in multi-homing router. Now, we are going to come back to later and talk about communities in more detail and talk about what are the difference between standard and extended communities, what are the well-known communities such as no export, no advertise, and local AS. But in this case, we're basically using the community as just a tag number that we can then use for traffic engineering based on signaling towards a service provider. Now, specifically, this RFC 1998 says that we can use communities as an application of the attribute to simplify the implementation and configuration of routing policies in a multi-provider internet. It shows how the community-based configuration can be used to replace the AS-based customization of the BGP local preference attribute, a common method used today. Now, essentially what this RFC outlines is that if I want to affect my inbound traffic flows, as we talked about previously, there's a couple different ways you can do this. Normally, you would do AS path prepending out, or you would set the multi-exit discriminator out, but there's nothing to say that the remote autonomous system cannot override your policy, because weight and local preference are higher in the decision process than MED and AS path, or AS path and MED, I should say. Now, specifically what this RFC says is that providers should stage a config so that they use a signaling policy such as this, that if your AS number were to be 3561 and someone signals you with the community 3561:70, you should set the local preference to those routes as 70. Or 3561:80, you should set them to 80, 3561:90, and so on. Now, essentially what this allows you to do is when you sign the peering agreement with your provider, which again is basically a legally binding document that you say, we're going to peer BGP, these are the attributes that we're going to exchange, these are the routes that I'm going to accept from you, and so on, they should provide you with this particular policy that shows what are the communities that they support for signaling. Now, you can find some of these in the RIPE documentation, and if you simply search for BGP community signaling policy, you can also see this website here that is 1sc.net that archives some of the different providers' particular community policies. But generally, these should be posted in the ripe.net when the AS is actually registered. You can find in here also the policies registered. So without having to search through here in detail, basically this one shows how AT&T implements this, where specifically AT&T is autonomous system number 7018, and then it says these are the particular communities that we are going to use. That by default, we're going to assign a local preference of 100 to all routes. So this is just the default iOS behavior. Most of the other platforms and vendors that implement BGP do the same thing. They're going to assign 100 as a default local preference. Then they're also saying, depending on how you signal me the communities, I'm going to adjust the local preference either up or down. The ultimate result is that affects how I route my traffic to you, me being the service provider. Now, the idea of them doing this is that the customer can influence how traffic is routed through the provider without having the provider to get involved in their policy. So beyond doing just the local preference, there's other applications for this where you can say, based on how I signal you the communities, and it really depends on what particular provider is doing it. For example, some of them support more detailed ones, like if you look at Cogent Communications, these are the particular strings that they use. So their AS number is 174, and then these are the particular numbers. But they're also saying, based on how you signal me, this is going to affect how I export it to my internal peers or to my geographic peers. So if I peer with you in US West Coast, and I peer with you in Western Europe, and I peer with you in Eastern Asia, then I can affect how, when I advertise routes to you, how you export them to your own network or to other portions of the internet geographically. So the end result is that by using these community numbers, which are basically just tags, I can control how the internet routes back to me without having to do AS path prepending or set the MED, in which case I can't really predict how that particular change is going to be affected. Because again, AS path and MET are lower in the decision process than either weight or local preference. So local preference would be preferred because that affects everyone in the AS, but local preference has to be set inbound. And again, the reason why we're doing this to begin with is that local preference is not a transitive attribute. You don't exchange it between eBGB neighbors, so I cannot signal you directly to say that you should locally prefer this as the reverse path to me. Now, in order to do this, though, you would have to stage the policy to begin with. So when the providers do the BGB peerings to their customers, they pretty much have a well-known policy that they say, I'm going to have a route map if I'm using iOS, or I have routing policy language if I'm using iOS XR, that I'm going to apply as inbound policy to this neighbor that says match predefined community numbers, and then based on finding these, I'm either going to set the local preference or I'm going to set other attributes like maybe whether the community is no export or local AS, or how I'm going to do prepending out to my peers, where the end result is that setting a community outbound from my side to you affects your outbound traffic back to me. So it's kind of a strange case versus what we saw at this point. It's an outbound policy affecting your outbound policy. So in other words, I'm basically doing reverse signaling to you in order for you to set the in policy to affect the out traffic. Because remember, it's always the reverse direction. So if we look at this within our scope of our diagram, let's say that we want to do this between AS100 and AS200. So from router 1, 4, and 6's perspective, they want to control how is traffic going to be routed as it comes in from AS200. So there's multiple entry points from AS200. So normally I would set something like the AS path prepending outbound in order to get router 3 to affect the traffic that direction. But it really depends on what AS200 is already doing with their decision. If they have a local preference higher already configured, then AS path's not going to matter. Okay, in this case, we're using the communities in order to trigger a policy that router 3 and router 5 would already have staged. So, for example, what we would need to do is to first match on the community attributes and then specify what values that they're going to relate to. So let's say in this case that we're going to have a couple different communities. We're going to say that if we were to signal you with 200:90, you set the local preference to 90. But if I signal you with 200:110, you should set the local preference to 110. Then likewise, we're going to do the same thing out to AS300. We're going to say that if we set it to you with 300:90, you're going to set the local preference to 90. So below the preferred default, and if you set it to 300:110, you're going to set the local preference to 110. Now, the whole application of this policy is going to assume that all of the routers are exchanging the community attribute when they do the BGP peerings. And in the case of iOS, that is not the default. So in general, in a practical situation, you do want to exchange the communities. So that's actually going to be the first change that we're going to have to make. So let's say on all of the boxes, let's say show run section BGP. And we're going to add onto basically all of these peerings, iBGP and eBGP, that we want to exchange the community attributes. So on router 1, we're going to say as we go to router 3, we're going to send communities. And the same thing with router 4. So router 4, send communities. And to router 6. Same thing on router 3. So let's just do this. Let's replace remote AS. We're going to replace this with send community. So basically applying this to everybody. Then on router 4 as well, this one we have just a couple. Send community. And the reason that you need to do this everywhere is that if I send communities to you and I give you the attribute, but then you don't send communities to the next top neighbor, whether they are IBGP or EBGP, you will strip the value from the update. And what I'm going to show here is an example of when the communities are transitive, and assuming no one is deleting your policy from the signal, you can influence an AS that is multiple hops away that you are not directly connected to. So it's an interesting application that you can actually do on the internet to indirectly signal a provider that you are not peering with. So let's add this also on router 5, and then we're going to need to add it on, let's see, we need it on 1, we have it already, 3, we have it already, 4 we did, we need it on 5, 6, and 7 as well. Okay, and unfortunately there's no command that you could just say by default send communities to everyone. You have to do it, at least within the scope of regular iOS, you have to do it individually. So let's say to router 3, send communities, to router 2, to router 4. And technically I don't need to send them back in the other direction, because it's a one-way negotiation. Just because I send communities doesn't mean you have to agree with it. It's not a negotiated capability, I should say. So from router 6 to 7, 6 to 1, and then one more, which is going to be lastly on router 7. Okay, so this is going to go to router 3. And to router 6, 67, 6, that should be enough. Okay, normally you would want to do it everywhere, but there's no default command to do that. So you would maybe put them in a pure template. The pure template has send communities configured, and then it would apply to all of the neighbors that you put into that template. Okay, so first, before we apply the policy, let's just look at signaling the community. Let's say that we are originating a route on router 6. Okay, so on router 6, we're going to create a prefix. Let's say it's a new loopback that is 6666, and we're going to advertise it into BGP, and we're going to set a community value right as we originate the route. So we're going to say on interface loopback 6, IP address is 6666/32, and then under BGP, actually I'm going to do something else first. Let's say router BGP, or let's say route map. Let's say route map loopback, and I'm going to say set the community, and I'm going to set the community to a particular number. Let's say 100:6. Okay, these other ones, like Graceful Shutdown, Internet Local AS, we're going to come back to later and talk about in more detail. For now, we're looking at just using this as a tag number. Okay, then under the BGP process, as we originate the NLRI under the network statement, so 6666 with a mask of /32, we're going to apply an attribute change right here. So in the previous examples, we were doing the attribute changes out to the neighbors or in from the neighbors. In this case, I'm applying it directly as I am originating the NLRI. Now, this should be successful, though, because I'm sending communities to all of the peers. So now, for example, if we were to go to router 2, once the advertisement gets all the way down to router 2, and if we show IPBGP 6.6.6.6/32, we should see that there is a community value that has been signaled, which specifically is 100:6. Now here it shows it in the decimal format, which is the old format, but this is just like the AS dot notation in the 4-byte AS. It's technically still the same number. It's just that we're looking at in decimal versus the 4-byte field. So you can change this if you want to. You would do this in global config. You say IPBGP-community new format. So let's say this on all of the routers just to be consistent, so we can see what the notation looks like. IPBGP community new format. Then on router 2, when we look at the show IPBGP for the particular route, okay, we can see that it does have those particular communities. Now, as of yet, we haven't configured the policy to enforce any attribute changes, so the community is not doing anything. It's just used as an administrative tag on the route. Now, the thing with the community string is that this is where a lot of the extensibility comes from. So we'll see later when we get to MPLS L3 VPNs, the extended communities are used to encode things like what's the OSPF type of route that it was originated from, what are the EHRP vector metrics, what is the route target value in the case of MPLS L3 VPN. So it's a very flexible field, and you could pretty much do whatever you want with it by writing your own extension to BGP. Okay, so next let's go ahead and prep the actual policy, where the policy is going to say that in AS200, if the routes are received with either of these communities, we're going to change the local preference to 90. So the first thing we need to do is to match the communities. Now, when you do this, if you didn't know that it works this way, the syntax is a little bit confusing, because if I were to say something like this, let's say route map from router 1 that says match community 200:90, set local preference 90. Route map from router 1 permit 20, match community 200:110, set the local preference to 110, and then a third sequence that says permit everything. Okay, then we're going to go under show IP BGP summary. Let's go to router BGP 200. The neighbor 155.1.13.1, we're going to use the route map from router 1 inbound. Okay, next let's assume on router 1 that we actually signal this. So let's give them the local preference, or let's give them the community 200:110. So on router 1, we're going to configure a policy. We're going to say route map, this is to router 3, so this is outbound. And it says set the community to 200:110. So I'm not going to match anything, just every route that I advertise out this particular direction, I'm going to signal with this particular community. So then under the routing process, we're going to say under BGP 100, router BGP 100, when I advertise routes out to the neighbor 155.1.13.3, use the route map to router 3 out. Okay, then let's clear the policy. Now from router 3, if we now look at the show IP BGP, did I say clear hard? Clear IP BGP, I should have said out there afterwards. Okay, on router 3, if we show IP BGP 2222/32, once the, or not 222, 6666/32, we should be here receiving the route in from router 1. Okay, we receive it in from router 1, and notice it has the community value. It has 200:110. Now, what's the first thing that you notice here that has changed from before? Okay, look at the other paths. Router 6 was doing the origination, and it was setting the community as 100:6. Router 1 then said set the community to 200:110, which worked, but what did it do? It deleted the old value and replaced it with the new one. So this is the default behavior, and this is important to understand. This is the default behavior when you set a community. The addition of the or the community value is not additive. So you're not just appending the string to the end of it. You're replacing whatever you signal with the new value. In most cases, when you set the community from a real implementation, you want to set the community as additive. And what this means is that you're not removing someone else's policy, you're just adding your policy onto the end of it. So if we show route map, what I actually should have said, instead of saying to completely delete the string, I should have said additive onto the end of it. Okay, this is one issue with this config so far. Then clear IP BGP star out. On router 3 then, if we look at the show IP BGP for the prefix, okay, we can see now it has both of the strings. Okay, also let's look at the policy we have on router 3. If we say show run section route map, it says if you have a community that is signaled as 200:110, set the local preference to 110. We apply this in from router 1. Okay, we can see the route map is applied. The community is there. The community is 200:110. What's the local preference of the route, though? The local preference is still 100. So what does this mean? The policy didn't actually apply. Okay, the reason it didn't apply is that there's basically a bug in the parser here that should have told us this is not what you actually mean in the syntax. Okay, there's a difference between when you set a community and when you match a community. When you set a community, this is the literal string that is inside the community attribute. When you match a community, you are matching a community list. And the reason that this did not give us an error is because the community list is a string. And it is valid to have a community list name whose name is 200:110. So we're not trying to literally match the community here. We need to call it from another step. Now, in most cases, for simplicity, you would just match the community list name to the community number or to the community name, but it's an extra step that you need to make sure that you understand, because otherwise you result in a config like this that doesn't actually do anything. Okay, what I should have said first off, or in addition to this, was IP community list. It is a standard list, and the name is 200:110 that says to permit 200:110. And another list named 200:90 that says permit 200:90. If we now clear IPBGP star in and show IPBGP 6666/32, now we see the local preference is actually updated. So again here, when we show run section route map or community, the problem is that this matching here is not the actual community number. It's a string, which the string is the community list's name, which then matches the actual value. So in other words, this is the tag here. But we can see now the policy is actually applied. If we show IPBGP, we can see that the local preference is higher, which means now that this is the preferred route. Now, if we look at this from any other device within the topology, for example, router 5, and we show IPBGP 6666, we can see that router 5 also learned the local preference being higher, and this likewise is now the best route. So what this is showing us here is that from the remote AS, by signaling the community value outbound, if the provider is pre-staged with the community policy inbound, it will change their local preference, and then you can affect their routing path. Now, what becomes even more interesting about this is that you can affect this through multi-hop ASs. Now, in this case, we are signaling directly from 1 out to 3. So let's look at this from router 2's perspective. How does 2 actually route the traffic to the destination? So from router 2, if we do a trace to 6666, it should be going out through router 5. As it stands currently, it's not going out through router 5 because it's the same problem we saw before with the next hop value not being reset. So to avoid this, we're going to do next hop self on all of these links. It's going to simplify the situation. So let's say that on router 3, when we show run, include BGP or remote AS 200, which is us. These are the ones that I want to reset the next hop to. These are my iBGP neighbors. So I'm just going to take this whole config here and then say this, instead of remote AS 200, this should be next hop self. Then clear IPBGP outbound. Same thing on router 5, who's the other edge router. So let's show run section BGP. And actually, let's say show run include router BGP or remote AS200. So those are my internal peers. Next hop, self. Okay, so now let's affect the policy. Clear IP BGP outbound. That should change the next hop. Same thing on router 3. If we look at this from 2 and now trace the destination, we should see that ultimately it should, and it may take a second here, let's say clear IP BGP inbound. We should see this leaving via router 5. So let's see, why is it not actually doing that? It says the next hop is 3 from 5, but that's not our best route. Our best route is 23.3 from 23.3. Okay, so it's going to router 3. Then on router 3, if we show IP BGP, the next hop is still... No, that's correct. That's correct, because we signaled it... we signaled the local preference to be high here. Okay, so we are going in the correct direction. But let's say that we were to do it in the other manner. Let's say instead of doing this on 1, we do it on 4 out this way. Okay, or alternately, we could do it the opposite. We could signal it low on router 1, which would make this a less preferred entry. So if we show run section route map, let's say that instead of setting this to 200:110, we set it to 200:90, which is forcing them to set the local preference lower, and then this should be the less preferred entry. So we should see now one of these, and actually from router 2 we can't see it because that's the advertisement would be hidden. Okay, now we leave via router 5. Okay, which is what we would expect, because when we're signaling this way, 200:110, it means router 3 should set the local preference to 110 in. This means it's advertised to router 5. 5 declares this one is invalid and this one is best, which means the only one that is reflected down is the route through router 3. Because, again, remember, depending on where you are in the topology, you're going to have a different view than other routers. So if you have full IBGP mesh, then you should know about all exits. But if you have route reflection, the route reflector is going to choose on your behalf and then reflect only that individual path to you. But let's say we now want to make a different change. Instead of doing this on router 1, where we want the traffic to come in this direction, let's say that we want the traffic to go this way. So think about, from AS100's perspective, what are the other mechanisms we can use to affect the traffic to be received in on router 6 when it comes from AS200? Well, one of the ways we could do AS path prepending, right? So from router 4 as we advertise out to router 5, from router 1 as we advertise out to 3, we could set the AS path length to be high. But what's the problem with this? The problem is that is relatively low in the decision process. If someone else is already setting the local preference, that's going to override the AS path. But remember here that the BGP communities are transitive. So what this means is by using this RFC 1998, you can end up in an interesting application where you could do something like this. That we could say on router 6, we're going to create a route map that says to router 7, set the community to 200:110. And if we show run, or not show run, show IP BGP summary, the BGP peer is 155.167.7. We're going to use the route map to router 7 out. Okay, then clear the BGP out. So send a route refresh out to 7. This means that on 7, when we show IP BGP for 6666/32/32, okay, we have the path now signaled as 200:110. Remember, this is a transitive attribute. This means that the advertisement is now going to go out from 7 to 3. When 3 gets this, and if we show run section BGP, actually what I did not do yet was to say I would need to apply this. I need to apply this policy in all of the ingress points. So instead of saying it's from router 1, let's say show run section route map. Let's call this instead our let's call this the community policy in. And then we're going to say that under BGP, the neighbors are 151 or 155.1.13.1. Route map is community policy in, and then the same thing on 37.7. So let's clear IPBGP start inbound and show IPBGP. Now look what happened. For that particular route, we now said when the route came in from router 7, it was indirectly signaled by AS100 in order to set the local preference to 110. So now even though the AS path is longer for the second route, this one is going to be preferred because we caused them to set the local preference higher inbound. And if we now look at the traffic pattern from router 2, we should transit through AS300 in order to get there. So in other words, if we were an actual BGP customer, AS100 here, and let's say that I'm peering with Level 3 and I'm peering with British Telecom, but I want to affect how AT&T routes their traffic to me. I can signal AT&T's community policy through Level 3 or through BT, and it implicitly affects them on the return path. So assuming that you own your address space and it's not getting aggregated somewhere upstream, these community policies should be transitive. And you'll actually see this if you look on the route servers. You'll see that a lot of the routes are tagged with random communities that someone is trying to use to influence some sort of policy. Like if we were to look at the show IPBGP, and let's look at, can't show IPBGP even? Show IPBGP. And let's pick any of these prefixes. Let's say show IPBGP 101.28.0/17. In general, you will see that there's all sorts of signaling that's going on with these routes. And the ASs don't necessarily have to be the ones that you're learning them from. Now, this may not be the perfect example of this because you see like here 3257, this is the ones that are being learned from 3257. Or 286, these are the ones that are being learned from 286. But in general, most of the providers don't reset the communities as they send them out because it's only a syntax change. The syntax change is what we did on router 1 was to say when you signal outbound, set the community as additive. Do not replace the value, because then you just continue to add it to the string. Now it does, of course, increase the update size because each of the communities is a 4-byte value, so it's going to get larger, but it's incrementally. So it's kind of an interesting application here, and again, this is documented as RFC 1998, an application of the BGP community attribute in multi-home routing. And then the end result is, as I said, you can signal the communities outbound, which affects the outbound path selection on the other side. So it's different than sending either AS path or MED out, because since those are lower in the decision process, you're not guaranteed that weight or local preference will not override them. But if I signal you to change your local preference, I can be guaranteed that that's going to affect your entire AS. Because as a best practice, you don't use weight. Because if you use weight, then you look at 1,000 different routers in the network and you have to trace it down to just one that's making some independent decision on its own. The service providers don't want to do that. And this is also why they implement this policy, because they don't want to be involved with customer XYZ, how they want to route their traffic. They just say, this is my template. If you guys want to use it, you can. These communities are set up. You just send them to me, and that's going to affect the return flows back to you. Okay, any questions on this section here with the community, basically community tags for the application of traffic engineering?